Welcome to Chapter 0, Section 11, Simple Probability and Odds. So some vocabulary here for you is number 1, probability. That's the ratio of the number of favorable outcomes for the event to the total of number of possible outcomes. So for example, if we're rolling a die, our probability of rolling a 1 or a 2 would be 2, and the total number of sides in that shape is 6. There are 6 different options, 2 of them which are 1 and 2, so your probability is 2, 6. Your sample space is the list of all possible outcomes. So that would be 1, 2, 3, 4, 5, and 6, because those are all the numbers that you could roll on a die. An event is equally likely when there are n outcomes, and the probability of each one is 1 over n. So for example, rolling a die, the probability of rolling 1 would be 1/6. Your probability of rolling any number is 1 out of the total number of possibilities, which is 6. So the probability of rolling a number on a die is equally likely. So we're going to find the probabilities. A die is rolled. Find each probability. So the probability of rolling a 1 or a 5. There's a 1 is on there once, 5 is on there once, so that's 2 out of a total amount of numbers being 6. Simplify it to 1/3. Rolling an even number, so our options 4, 5, 6, those are all our options. 2 is even, 4 is even, 6 is even. So there's 3 options we could have out of a total of 6. Simplify that down to 1/2. Vocabulary, a complement. The probability of an event happening and the probability of an event not happening. The sum of complements always equals 1. So the probability of rolling 1 would be 1/6. The probability of not rolling 1 would then be 5/6. And just to double check our work, if you add them together, they equal 6 over 6, which is 1. So the probability of an event happening and it not happening are complements of each other. They add up to 1. So we need to find the probabilities here. A bowl contains 5 red chips, 6 yellow chips, and 10 green chips. 1 chip is randomly drawn. Find each probability. So one thing I'm going to want to know is how many chips we have total. 10, 6, and 5 gets us 21. So the probability of drawing a blue chip, well, we only have red, yellow, and green, so the probability of drawing a blue one is 0 out of 21, or just straight up 0. You can't draw a blue chip if there isn't a blue chip in there. Drawing red or yellow. So that would be 5 plus 6, which is 11, out of the total amount of 21. And then the probability of drawing not green, which would be drawing red or yellow. So that's the same, 11 out of 21. The complement for drawing not green would be drawing green, which would be 10 over 21. Some more vocabulary is a tree diagram. It's a method for counting the number of possible outcomes. So down here I'm going to demonstrate how to do a tree diagram. Wow. So school baseball caps come in blue, silver, or white. The caps have either the shield or JWP. Use a tree diagram to determine the number of different caps possible. So we could have a blue cap, I can't talk today, with the shield or with JWP. We could have a silver cap with the shield or JWP. See, we're branching off like trees. And we could have a white cap with the shield or JWP. So our options is blue and shield, blue and J-dubs, silver and shield, silver and J-dubs, white and shield, white and J-dubs. So our total number of caps possible is 1, 2, 3, 4, 5, and 6. So 6 different caps can be created. You can also use the fundamental counting principle. So that relates the number of outcomes to the number of choices. Here we have an ice cream shop offers 1, 2, or 3 scoop ice cream among 12 different flavors, and they can be served in a waffle, sugar, or in a cup. So our first step is the amount of scoops. There are 3 different options for the amount of scoops. There are 12 different options for flavors, and there are 3 different options for the ways that it is served. In order to figure out the total number of possible choices, you can just multiply all of those together. So 12 times 3 is 36. 36 times 3 is 108. So there are 108 different combinations for ice cream here at this ice cream shop. In our second problem, it says Jimmy needs to make a 3-digit password for his logon name on a website. The password may include any digit from 0 to 9, but digits may not be repeated. How many possible 3-digit passwords are there? So we have 3 different spaces where we could put something. 0 through 9 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 different options that we could have in our first place. But we may not repeat digits. So once we use up 10, now we're down to 9 because we can't use that other number again. So there are only 9 options for the third one, or second one. And for the third one then, we lost 2 different options, so it's down to 8. And what you do is you multiply them all together. 10 times 9 is 90, times 8 is 720 different possible password combinations. And finally, our last vocabulary piece is the odds. That's the ratio that compares the number of ways an event can occur, the successes, to the way it cannot occur, to the failures. So we want to find the odds of rolling a number less than 3. So if all our numbers are 1, 2, 3, 4, 5, and 6, the numbers that are less than 3 are 1 and 2. So our odds are 2 to the number of ways it can't occur, 4. You can write it as a fraction 2 to 4, or you can write 2 to 4. Both of those represent the odds. So your probability is the number of events that it can occur over the total number of events. The odds is the amount or the number that it can occur over the number of ways it can't occur.